Let's algebraically test these functions for symmetry. To do that, we'll test if they are even or odd. To do that, we plug in negative x. So first we have negative x to the sixth plus 4 times negative x squared minus 2. Simplifying this, we get negative x to the sixth plus 4x squared minus 2. Notice that the result we just got is the same as the original f. We plugged in f of negative x, and when we simplified, we got the original f of x. This is by definition an even function. And since this definition says we have an even function, we know that we're symmetric about the y-axis. Y-axis symmetry. In the next example, we again want to determine symmetry by determining whether or not the function is even or odd. So replace all of the x's with negative x. We have negative x to the 7 minus 3 times negative x to the 5th plus 2 times negative x cubed minus 1. Simplifying this, we get negative x to the 7 plus 3x to the 5th minus 2x cubed minus 1. Recognize that this equation is not the same as what we started with. So right away we can say that this is not an even function. We can't automatically say it's odd though. It's possible that it's neither even nor odd. So to check for the other option, to check to see if it's odd, we will factor out a negative 1. So in the result we just have, factor out a negative 1. We get x to the 7 minus 3x to the 5th plus 2x cubed plus 1. Now you want to ask, is this inside the parentheses the same as what you started with? Is this the same as the original g? And notice it's not. It's very close, but notice on the end, the constant in g is negative 1, and the constant inside our parentheses is positive 1. So the inside of the parentheses is not the original, which means it's not odd. So we have no symmetry here. It's not symmetric about the origin or the y-axis. In our final example, again, we're looking for symmetry. To do that, replace x with negative x. 2 times negative x divided by negative x squared plus 4. Simplifying this, we get negative 2x over x squared plus 4. This equation is not the same as the original h function, so we know it's not even. To test to see if it is odd, we will take this equation and factor out a negative 1. We can pull the negative out of the numerator or the denominator, but not both. In this case, let's pull it out of the numerator. We're left with 2x over x squared plus 4. Notice this time the inside the parentheses is the same as the original function. So we calculated h of negative x, and it returned negative h of x, which is the definition of an odd function. And since we're looking for symmetry, we know that it is symmetric about the origin. We have origin symmetry.